handy dandy camera that is mobile. I can move it around, so we'll see how well that works. I'm going to get up real quick, just make sure my lights have maximum time off before I have to get up again. Okay, so what we are doing is we're going to start talking about chemical reactions. You will all need some notebook paper or your science binder if you have one, science composition book, something that you're going to be able to write and take notes with. So I am going to randomly pick a couple of you to answer some questions. Shrieker, how are you doing today, sir?
I'm good, Mr. Schroeder. How are you?
I'm doing pretty good. Do you know anything about bath bombs?
Oh, yeah, bath bombs.
Tell me what you know about it. Just tell me something about one thing.
They're made of like different types of chemicals.
Okay. Oh, there's Nolan. Nolan's in here now. Okay. Jagadish, what do you know about them? They fizz when you put them in water. Okay. Sahana, do you know anything about bath bombs?
Well, they're colorful sometimes.
Sometimes they're colorful. Okay. Juliana, do you know anything about bath bombs?
Um, Not really. All I know is my sisters like them, and I think it's cool because as soon as they touch the water, it like explodes.
Okay.
My sister uses those.
Your sister
Yeah.
does too? Ramchan, you said you know something about them. What do you want to add? They're made of some type of chemicals, so they dissolve whenever they hit water. Okay, so and these are all very true. What I am using is I have a package here, Dr. Teal's Ultra Moisturizing Bath Bombs Lavender. So what I want you to do is I want you to create a T-chart. And on one side, I want you to write notices. And the other side, wonders, like we did way back when. And what I'm going to do is I'm going to use the camera and we're going to take a look at a couple things. Now, notices are just like observations, okay? It's only things that you can see, and I'm going to add a couple things to this because you're not here to experience it. So I'm going to add a little bit of more information to you as we do this. So here goes the camera. Hopefully I don't make anybody too dizzy. So here's a beaker of liquid. It is, Anya, you can't see anything? Can you guys see the beaker, most of you?
Yes, sir.
Okay, Anya, you still can't see it? Okay, good. All right, so this is a beaker of a clear liquid. It is odorless. It is room temperature. As you can see, I get really, up close. It is pretty clear. It is in a 1,000 milliliter beaker, and there is approximately 500 milliliters of liquid. and I'll go so far because I mean I've told other classes this. It's water, as you may or may not have already figured out. Never presume something is something that you don't know. But yeah, so I have a room temperature 500 milliliters of water, clear, odorless. I mean, I looked out inside of it, nothing in there. So write down your notices on that. And then this is the bath bomb. It is about 2 inches in diameter. It smells flowery. If you were familiar with different scents, it is lavender is the smell. It's solid. I can squeeze it. I drop it a little bit. It leaves some, little powdery residue when I squeeze it or when I drop it. Is there anything anybody wants to see or for me to do real quick on an observation for notices?
The color white.
It is white. It's not pure white, but it is white in color. I'd call it just regular white. It's kind of sandpapery when I touch it. It's not really smooth. It has a like a fine sandpaper texture to it. Okay. So I'm gonna put the camera back over here for just a second. So what I'd like you to do is you wrote down your notices, write down a couple of wonders, and then we're gonna come back and talk about them real quick. In just a second, I'm gonna walk around again, make sure my lights don't shut off. It's pretty sad I gotta keep doing that. Okay, Surpath, what is something you noticed?
I noticed that the bath bomb is shaped like a sphere.
Okay, it's spherical in shape. Very good. Sid, what's something you noticed?
I noticed that it's crystal clear. There's like nothing in it. It's crystal clear.
Talking about the liquid. The liquid is crystal clear. Okay, Viraj, how about you?
I noticed that there's like a little ring from the bath bomb.
Okay. Yeah, you got it almost makes it kind of look like a planet. Almost looks like Saturn or something like that. Very bad rings, but welcome, McCready. What we're doing, young lady, is we have just made some observations on a liquid right here. 500 milliliters of water at room temperature. And then we're looking at a bath bomb. And we're writing down, we made a T-chart, like that right there up on the board. Notices and wonders. I'm also recording this, and we're going to come back and I'll post the video when we're done.
Okay. Do I need to write it on my science notebook?
I would, yes, ma'am.
Okay.
And again, like I said, if you want to start from the very beginning with the video, you'll be able to catch up without any problems. One more, let's see, Elijah, what is something you noticed or wondered about?
For the water, the bath bomb, I said it is, it's pretty large in size.
Okay, all right, not bad. And actually, I'll say one more. Carson, how about you? You got anything you want to add to that?
So can I do a notice or wonder?
Yep, Either one. Either one.
Okay. I had a wonder. You said the bath bomb smells like a flower. Why does it smell like a flower?
Okay, so very good. Yeah, it smells like a lavender flower, and I'm smelling it like that's not going to help you. But yeah, okay, that's a good wonder. Okay, so what we're going to do now is I have the bath bomb here, and let's see, make sure the water's on here. So I'm going to put the bath bomb into the water. And we're going to watch it for a couple minutes.
Are we supposed to write any notices?
Yeah. Oh yes. I'm sorry. Yeah. Draw a line and write down your new notices, things that you notice that are going on. Can you hear the noise?
Yes, sir.
Do you also do wonders?
Yes. Please also do wonders. I'm sorry I did not explain that better. My apologies. Okay, actually. So it's definitely getting a lot smaller. The glass has actually gotten a little bit colder. Not much, but it's a little bit colder. Just teeny tiny now. Originally, I had 500 milliliters. I'm a little bit over 500 milliliters now. Not much, just a little bit. Maybe about 510. And there's just a teeny little bit still down there, which I think you can see.
Didn't the water rise because, like, since there's a bath bomb in it and since it's solid, it'll make the water rise a little bit?
That's something you might want to wonder about. I mean, I know the answers. I don't want to tell you the answers. That'd be an unfair advantage to you.
How many notices and wonders should we write down?
You write down whatever you notice and whatever you wonder. There is no amount.
Okay.
All right, so I'm going to break the camera away from that. Come back up here to me.
You're just showing her?
Yes.
So I saw that the liquid was swaying back and forth. So was that because you were turning it, or was it because of the bath bomb?
That was because I was turning it. There was motion going on, and then twice I put my hand in to pull out what was left of the bath bomb to show you.
Okay.
So now the reaction is no longer going on. We have this is the liquid now, what it looks like. So you might want to put those in your notices. Sean, that's okay. A lot of people are experiencing some bad internet with the weather. one of the reasons why I'm recording this. So what you missed, I don't know exactly when you popped out, sir, but I put the bath bomb in the liquid. So we put it in here. It fizzed quite a bit. It went from being a clear liquid to I'd almost call that a milky clear liquid. Okay, so Nolan, what is something that you noticed about the reaction?
I noticed that as soon as the bath bomb went in, the water started turning murky.
Okay.
And the bath bomb got visibly smaller really quickly.
Okay.
And
Good.
that made me think it was coming off the bath bomb, which made the water murky.
Okay.
Mr. Schillinger, you're not recording.
I should be. Yeah, I'm using Screencastify. It's on. It tells me it's on. But thank you. Thank you for keeping me straight. I have forgotten to start recording a couple times. So, okay. Daniel, how about you? What's something you noticed or wondered about what happened?
I noticed that the bomb was fizzing a lot, and the beaker was getting really bubbly.
Okay, so we had fizzing and bubbling. Hima, how about you? Anything different?
I wondered if the bath bomb will react the same to any type of liquid, not just water.
Okay, that's interesting. See if it does anything different to any kind of different liquids. Jacob, what about you?
I wondered what was in it to make it fizz like that.
Okay. Let's talk about a couple things real quick. One is I've heard over and over again the term fizz or bubbles. Joshua, what are we talking about when we say fizzing or bubbles? What do you think we might be meaning?
Because it looks exactly like it's fizzing, or exactly like any other thing.
But what do we mean when we say fizzing?
It's moving.
Okay. I know some of you have your hands up. I'm going down the list. I'm trying to make sure I ask everybody a question. So I'll probably come back to some of you. Austin, do you want to give it a shot, what it might mean? Austin? Austin. Mr. Schillinger to Austin. Yeah, and if he's AFK, that means he's not in class. All right. Ladies and gentlemen, that's the quickest way to be turned into an absence. You're not supposed to go AFK. That's one of the reasons why I'm really kind of hesitant to let some of you be cameras off. Arsh, how about you?
A wonder or notice about the bath bomb?
Yeah, whichever one. About the reaction after we started it.
My question was, how long would it fizz for?
Okay, it fizzed for about 3.5 minutes. But that's a good one.
And would the color of the water go back to normal after a few hours, or would it stay?
Oh, that's a very good question. Okay. I'm gonna come back to Akriti on this one. Akriti, I started asking about fizzing. Do you know what fizzing or bubbling is?
Well, in my opinion, I think it's like rising up,
What's rising up?
like uh, like the water level rising up like just a little bit, and the bathroom like causing it to rise up just a little bit.
Okay. Not, that's interesting. Praneeth, how about you?
Do you want me to tell a wonder?
No, I'm trying to get to this fizzing. What is fizzing? What do we mean when we say fizzing?
I think the bath bomb causes some bubbles to go up, and the bubbles pop when it comes to the top of the glass.
Okay, we're getting closer. I know I got a couple of you who are about to pop here if you don't get to answer this soon. I want to ask two more people. Anya, what do you think? What do you think this bubbling or this fizzing is?
Um, the bath kind of like reaction to the water.
Okay, yeah, that's we're on the verge. We're almost there. Abigail, how about you? Miss Rooney? What is this bubbling? What is this fizzing? What are we talking about when we do this?
Bubbling is like when it makes bubbles, I guess. And fizzing is like what the bath ball was doing when you threw it into the water.
Okay, but all right. Elijah, go for it.
So fizzing is like, so the bath bomb is solid, but in the inside there's probably pockets of air, and when it continues to like shrink, it's releasing air.
Not exactly. Nolan.
I was gonna say the same thing, but I was just gonna say that the bubbles are probably pockets of um, carbon dioxide rising to the surface of the water.
Okay, not quite. Carson.
So this is just a guess, but I think it might be a chemical reaction.
It is, but what is happening to make the fizzing or the bubbles?
So maybe it's energy inside of the bath bomb because energy rises. So maybe when you put the bath bomb inside the water, it causes it to bubble because it has energy. Maybe I don't know.
All right, last one. Ramchan, what do you think? Sorry, Ash.
I'm not sure if this is right, but
That's
is it,
okay.
like, heat rising or like something in that area?
Okay, no, not quite. I mean, guys, there's a lot of good answers, okay? And this is the way we're going to be doing this is we're working together to solve the problem, okay? So I'm going to be a little crude right now, but I'm not going to say any slang terms for this. Imagine you're in a swimming pool, or you're in a bathtub, or your little brother or sister are in a pool or a bathtub, and they make bubbles. What are they doing? What is that? Juliana?
Okay, I think I get what you're saying. So in the bath bomb, there's air, and
Yeah.
whenever it hits water, the air is being released.
No. Creedy, what did you type in chat?
I put gas.
It's gas. Now that's what I mean. When you're in a bathtub or you're in a pool and you make bubbles, you created gas, which is a chemical reaction. Okay, your body is breaking down food, and as it breaks down food, it releases a gas. Now, the mistake that a lot of you had is the bath bomb does not have the gas trapped in it. There's not, I mean, there may be little pockets of air in there, but that's not what's causing the fizz. There is a chemical reaction taking place. Arsh, you want to say something?
So what I thought was last year in science we learned that cold energy rises to the top of the heat, energy stays at the bottom. So what I thought was as soon as the
Reversed. That's actually the opposite way around.
oh my bad, then it won't work.
Okay, so one sign of a chemical reaction is the production of gas. Okay, so I know if I put something in something else and it starts to bubble, it starts to fizz, it starts to create a gas when it shouldn't, a chemical reaction is taking place. Now, chances are that gas is carbon dioxide. And some of you mentioned carbon dioxide, but you were saying that carbon dioxide is trapped inside the bath bomb. It's not trapped in there. We're mixing things together. We're causing chemicals to come together, and a byproduct of that chemical reaction is a production of gas. Does that kind of make sense? Okay. This was the big takeaway from today. Now, what we're going to do is either today, this afternoon, or tomorrow morning, I'm going to send you a list of... Who is that?
I don't know. She doesn't know that she's muted.
Oh, okay.
Sorry.
It's all right. I'm going to send you a list of household things that you might have around your house. That's going to help us investigate what is causing the bath bomb to do what it does. Okay? And if you don't have them, that's great. But if somebody has one, I'm going to ask you to maybe share your camera, mix something together if you got the products. If nobody has the stuff, don't worry. I got it all, and we're going to investigate this together. But I'm trying to find some ways to get everybody involved in this a little bit. I don't want you to have to go out and buy stuff, but these are going to be things like baking soda, maybe like lemon juice, Epsom salts, different things you might have around the house, okay? But I'll send out the list either this afternoon or tomorrow morning. I'll send it to you via Gmail and put it in the Google Classroom. Yes, Juliana?
What if you actually have a bath bomb?
Well, that's good, but we're going to try to find out what makes a bath bomb do what it does. So we have to try the ingredients that go into a bath bomb. Now, hold on just a second. I want to make sure my light doesn't shut off.
Hold on, give me a second.
Okay, so like this was our big takeaway for today, but there's a couple other things I want to talk about real quick. And the main one is another thing that I heard you guys talk about was the dissolving. We look at this and we see it's a milkish, clear liquid. Now, if I come over and I pour the liquid out, you don't see it, but I'm pouring it out at the sink. There is a white, powdery, it's still wet, but there's a lot of the bath bomb still left in the bottom of my beaker. It is a Sahana, yes, and the thing is, it is a mixture. It's not a compound. And what that means is, to a degree, I can get some of the bath bomb back. Now, the thing is, we're going to try to investigate, am I making a complete mixture, or is there a chemical reaction going on? Are some of the substances changing? Because how many of you have ever gone out, got a bottle of water, you get these flavor packets, and you put them in a bottle of water, right? You shake it up, and in this case, this is cherry, so my water's going to turn red. And I drink it, and it's basically cherry Kool-Aid. You guys ever do these before? You know, whether it's lemonade, Kool-Aid, you know, whatever. Well, the interesting thing about this is I can mix it into a bottle, shake it up really good, and I can pour it into a beaker, and I can put the beaker on a hot plate and let all the water evaporate out. And on the bottom of my beaker, I'm going to have a crystally red substance that I can scrape up, grind it back up, and it will be just as much powder as I have right now, and I can put it into another bottle of water, and I will have the same exact thing again.
Isn't that separating the mixture by like evaporation?
That's it.
I
Yeah.
put food coloring into water, and then I just like boiled it, so then it left a red powder.
Yeah, that's exactly what you do. And the interesting thing is, like the ocean. You know, I used to live in the North Bay of San Francisco Bay. And I used to drive from one side of the bay to the other side every day on my motorcycle. And all along Highway 37, they have these big channels. They're probably about 12 feet wide, probably about 6 to 7 feet deep. And what they do is they would open these floodgates, and ocean water would come fill up these channels, and they'd shut the gate. And then they'd wait. And they'd wait. And the water would start to evaporate away. And then they had this orangish looking crust on the ground. And these big tractors would come, scoop all that up, and take it to the Morton Salt Factory. And they would process the salt, and you eat that on your food, straight from the ocean. There are places in Utah, this Great Salt Lake. They take that salt right from the Salton Sea there, and they sell that as salt. I've been to Bolivia in the Uyuni salt flats up on the top of the Andes Mountains. They take salt there and they sell it for people to use on their food. Himalayan salt is kind of pinkish in color, but it's the same thing. It's from ancient oceans. So even though it's salt water, we can take that salt right out of there. You know, it's kind of a neat thing. Why, though, do I have some of this bath bomb left? I left it in here for about 10 or 15 minutes. It should have dissolved. Why didn't? Anybody know?
Is it because like the original the original bath bomb was capable of like dissolving and like taking place in a chemical reaction because it had some of those chemicals in it at that time, but then now at the end it doesn't have it?
No, that's not quite it. Arsh?
Maybe there's not the amount of water for the bath bomb down, though.
Right. Because I had 500 milliliters of water here. This is called a bath bomb. Let's see you put 500 milliliters of water in a bathtub and try to get into it. You ain't getting very wet. Your tuchus might get wet when you sit down in the bathtub, but that's about it. Okay? So imagine a bathtub with 15, 20 gallons of water in it. You drop that bath bomb in there. There's not going to be any kind of mixture left at the bottom of that. You know, when I was a kid, when I was around your age, not to call you kids, you're young adults, me and my best friends, we used to always go to their house for lunch when we were in high school. Always had two things, peanut butter and jelly sandwiches and Nestle's Quick chocolate milk. And the instructions were to get an 8-ounce glass of milk and put 2 heaping tablespoons of chocolate powder in there, stir it up, and you have the perfect chocolate milk drink. Yeah, no, I don't think so. Instead of 2, I put in 4 because I wanted that extra chocolatey goodness in there, right? Well, I sit there and mix, 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 mix. And lo and behold, when I was done with my glass of milk, I had this big thing of chocolate powder on the bottom of the milk because I saturated, and that's a word that you're going to be using eventually, saturated the liquid. I saturated the milk. It could not take any more chocolate milk. The 500 milliliters of water I had in here, I saturated it with that bath bomb. This could not dissolve in the water. There was nowhere for the little particles to go. Does that make sense? It has to have somewhere to spread out to. So we're going to kind of wrap it up right here. I'm going to actually shut the video off real quick. What I would like you to do is, we've talked about a lot of different things.